A warm welcome to the second demo session of the Matlab interface. In the last session, we were introducing the Matlab interface as a platform for performing computation. So in this demo session, we'll be extending that further onto writing a large number of programs using the M file in Matlab. We'll briefly look into writing a function and we'll introduce to plots, stems and histogram in Matlab. So let's get started without any ado. So first of all, I will introduce the concept of an M file. So let me just make a remark before I begin. This Matlab window I have changed for the purpose of this video tutorial. So here I have opened two tabs. The one is the command window, which we are now familiar with. I have removed all the other tabs which I showed you in the introductory video. Now there is a second tab which I have opened, which is called as the editor, or which is the M file which I am going to use for running the program. So first let us come to the command window and let us see how to open a new M file. So if you go to file menu, you can see a new button there and you can opt for a blank M file. So M file stands for the Matlab file. It is a file that runs only on Matlab and its other equivalents, for example the octet. So if I open the blank M file, it will be opening up in the editor window and it has nothing being written into that. So let us write our first program. So as in the case of any programming course, let us write the hello world program. So let us write hello world program. Okay, so this is the simplest program. So we'll use the disp function here. So disp means display. So it will display hello world now. Hello world in the command window. So first let us save this. And to run this, we can either go for the run button that is available within the editor, or you can press F5. So let us press this run. So once we press run, you can go to the command window and see what the result is. So we have got the hello world now. Now if you see, there are some previous things that have come before the hello world. So first we can clear the command window and then run it once again. So the command for clearing is CLC. So clear the command window first and then run the code. So now you can say you can get the hello world without any other previous outputs in the command window. So that was the first program. So if you see, Matlab gives a good editor for writing codes, and most of the codes that we write are just conversions of English. And if you're familiar with the C programming, you will see there are a lot of connections with the C programming, and you will see a Matlab program is much more easier to write than a C program. So without talking more about the advantages, let us move on to the first program. So the first code that we have written is the hello world, which is shown again. So here we have used the fprintf to write the hello world. Now I have used a clear command here. So the clear command is for clearing of all the variables that are there in the workspace. So suppose I show you the workspace now. So let me just add the workspace. So if I add the workspace, you will see there is nothing in the workspace right now. So let's add some components in the workspace. So A equal to 1, B equal to say 2, and we'll see the workspace. Now these two variables are there in the workspace, or it means that while you are in this present workspace, you can use these variables at any point of time. Now if I use a clear command, it will erase off those variables from the workspace. So if you have some program that is being run before the intended program, all the variables used shall get deleted when I use the clear command. Now let us go into the second program. So this program is to print the numbers from 1 to 10. So let's see how we do that. So this program introduces you into the for loop. So if you see this, we have used the for loop here. So the for loop is written in this fashion with the index variable a, and if you want to run this loop 10 times, you can write the index variable starting from 1 to 10. Now unlike the C programs, if you want to index an array, the index starts from 1 and not from 0. So please make a note of that. And the fprintf appears again, and there is a %d that I have put inside the fprintf, so which represents that it is a decimal number that I am going to display. So let us add a clear command window and just run this cell. So this code is what I'm going to run. So you have to press this evaluate cell button that's available. Now if I evaluate that cell, go to the command window and you can see the numbers from 1 to 10 being displayed. Now if I replace this %d by %f, let us see what happens. What happens is now it is represented as a floating point number. So we can replace by %d itself. So that is the printing job that can be done in Matlab. Now a third program introduces you to the second kind of loop that we can use within Matlab, which is the while loop. So here the program is written to print all the prime numbers in the range 1 to 20. So let me tell a few words about a prime number. So a prime number is a number that has only two factors. One is itself and the other is 1. The remaining numbers are called as a composite number. So if you take the range from 1 to 20, 1 is neither prime nor composite. So that is the axiom or the hypothesis for the number 1. Now again we start the for loop. Here we define a flag. This flag is defined for knowing if it is a prime or a composite. So if it is a prime number, the flag remains as 0. If it's a composite number, I make the flag as 1. So what I do is to check whether a number between 2 to 20 is prime or not, I should divide by all the numbers previous to it and see if any one of them is a factor. But I can easily verify that a factor can be at most be a by 2. So a factor of a number can at most be half of that number. So because of this condition, I shall verify the numbers only in that range. So while m is less than the ceiling of a over 2, if so mod means the remainder when I divide the number a by m is 0 and m is not equal to 1. So I remove the factor 1 and except for the factor 1, if there is any other factor that appears, then I know it is a composite number. So immediately I change the flag to 1 and break from that loop. Now if by chance no number in the range 2 to a by 2 divides the number a, then I know it is a prime number and hence the flag remains 0. So when I come, I just need to check whether the flag remains as 0 or not, and I print that number, that is a prime number. So let's run that cell. So remember I had not cleared the command window, so we'll get the previous result also. So yes, we have got the numbers 2, 3, 5, 7, 11, 13, 17 and 19, which are the prime numbers between 1 and 20, so which is the right answer. That is the introductory programs that are being written in an M file. Now if the program is short, people do prefer to write them in the command window itself, but if it is for the purpose of showing it to somebody or sending the code to somebody or for later reuse, it is better to write a M file and keep it documented. Now one remark that has to be made while writing an M file is that you have to comment the code accurately and wherever necessary. So if you see these programs, I have written a one-line comment on what the program does. So the comment is written by starting with a percentage symbol. And if you see in my code, there are two percentage symbols at the beginning of the code and it represents a cell. So we will not get into the details of a cell, all those are there in the documents in the help of the Matlab. So that concludes the first program. So let us move into the second program, which introduces a function. So as you are familiar with a function in a C program, there is a similar correspondence in Matlab also, and many things are written as functions in Matlab. So function is some generic code which applies to many number of inputs. So here I have written a code for implementing a calculator using Matlab. So we know a calculator what it does, it takes in two numbers. So this is a simple calculator, it takes two numbers and it performs one of the four operations: add, subtract, multiply or divide. We use the concept of switch and case to implement this. So it is a switch case implementation which is very similar to the implementation in a C program. So what the switch does is that it takes the operation which is represented by the variable OP and it first of all makes it into a lowercase string and it compares the string to one of the known strings. So I have added 3-letter strings for addition, subtraction, multiplication and division. The first three operations are very direct because you need not check for any abnormality in these three, whereas the division operation you should not allow division by 0, hence you should display an error that division by 0 is not possible. And wherever the result is undefined, we write NaN or it represents not a number. So let us see how we can get the output of this calculator. So we go to the command window and clear it first. A function is called by the function name. So our function name is calculator. So what I do is I type in the first four letters, and if I enter the tab button, it shows me all the possible functions within Matlab that starts with calc. So AB has to be defined. So let me define A and B to be 10 and 15. And let us perform, say, addition. Oh, so it's good that we got an error right now. So let me explain what this is means in this context. So it says that undefined function or method calculator for the input arguments type double. So what it says is that this calculator function is undefined within the path that I have mentioned. So what we should do is we should first of all change the path of so to change the path, it's better to go so where I have written. So current folder is changed now. So I think now it should give me something. Yes. So if I perform addition, I get 25. Let us try division. Let us make b equal to 0 and try division. So now it gives me an error saying that division by 0 is not possible and the returned value is not a number. So that means that my code is working fine. So that is the implementation of calculator using a simple switch case concept. Now next I recommend the listener to implement a calculator functionality within Matlab but using a GUI interface. So if you go to help of Matlab, you will get familiarized with using GUI interfaces for adding buttons and how to link with a code written in Matlab. So I recommend the listener to implement the GUI for the calculator using the 4 operations. Now let us move on to the third part of this lecture, which is plots in Matlab. So a plot is a pictorial representation of the data that we would like to analyze. Now in this program I have written 3 codes, one showing a plot of some measurements taken from temperature sensor. The second one is a plot representing 2 functions, and the third one is a histogram plot. So let us take the first one. So I have collected some measurements from a sensor which measures the temperature. So we have that being stored in a variable MEAS showing the measurements. And in Matlab you have a function called as the length of a array. So this gives me how many elements are present within that array. So if my measurement length is length of measure, I number them from 1 to length of measure. A plot function plots x versus y. It gives me a 2-dimensional plot. An x-axis will be present as well as a y-axis will be present. So along the x-axis I'll mark the index or the time at which I had got the measurement. So let us run this part and see what I get. So I get this particular plot. If you read the title, it says it's a temperature measurements by the sensor, and what is plotted on the x-axis is the time, and on the y-axis you get the temperature in degrees Celsius. So we'll see that at time equal to 1, since we have numbered 1 here, it starts at time equal to 1, you have 28, then it rises to 30 at time equal to 2, and so on and so forth. So if you see, as the day progresses, the temperature comes down after a point of time. So you can see that this is the peak temperature that is there on the day. So analysis become a lot more easier with graphs or plot. Now let us move on to the second plot. Here we are plotting a function which is a sinusoid of frequency 2 Hertz. So to plot a sinusoid, we should first of all collect points from the sinusoid. So before I run, let me just show you just one plot. So for this I can just comment that. So if I comment a part of the code, only those part will be deleted from the remaining when I run the code. So if I run that, I get a sinusoid of frequency 2 Hertz. So as you can see on the time axis, at time point phi 1 cycle gets completed, and by the time 1 second you get 2 cycles to be completed, which concludes that the sinusoid has 2 Hertz as the frequency. Okay, so that is one sinusoid. Now if I want to see what is the difference between a sine wave as well as a cosine wave. So the difference between a sine wave and a cosine wave. A sine wave, when shifted by a phase of pi by 2, you'll get a cosine. So I plot this in the same graph by using an operation called as hold on. So if I hold on, I shall get the two plots together in a single graph. So when I run this, I get two plots within the same. Now the one in red is the cosine wave and one in blue is the sine wave. So while plotting, Matlab uses the default color blue if you do not specify anything. Now here I have mentioned the line width to be 2, which adjusts the width of the line while plotting. And if you see the second plot, the one in red, I have explicitly mentioned to plot it in red. And the line width is mentioned to be 2. Now there are some other features of plot which I can use, which are grid as well as axis. So if I enable the grid, what I get is the grid being enabled now. Now there is also another thing for axis. So let us see what we get for the axis. So if I adjust the axis, I can elongate all the sides of this graph. So I get a better visibility of the plot. So now there is a spacing from a negative time axis to somewhat extended time axis over here. Alright, so that is the plotting of a function. Now let us go into the third kind of plot, which is called as a histogram plot. So the histogram plot gives you the frequency or the number of occurrences of a particular value within the measurements that you have made. So we take the same temperature measurements here, and you would like to know which is the frequency or what is the frequency of occurrence of a particular value of temperature. So if I run this histogram plot, which is represented by hist, I shall get the following. So this is the plot, and it shows me that the value 31 happens the most. It happens 3 times in my time. So from a histogram, it is very easy to compute the mean, median, all the statistical properties of the temperature measurements that I have made. So let us conclude this lecture by giving a summary of what we have done. So in this lecture we had created an M file, and so a few basics of writing code in Matlab. Then we started working with functions, which is a very useful tool in Matlab. And the third is plots and histograms, which is used for data analysis and representation. With that, we conclude the second demo session. Thank you.